Hello, thank you for watching this video. So in this video we're doing question 1 of September 2023 question paper from the Northwest Province. So unlike the other days, I have guests today, so I'm performing in front of people. So let's go. So question 1.1, read as follows. Solve for x. So you are given 4 equations here from 1.1.1 to 1.1.4. So let's go. So the first one is this one here. So they're saying solve for x. So as you know, this is a quadratic equation, right? So what do? If you have a quadratic equation, you always want it in the form ax squared plus bx plus c is equal to 0. So you want your quadratic equation to be always in this form. So which means you have to transpose this to the left hand side. So what do we have? You will have x squared minus 5x is equal to 0. So this is the situation that you want with the quadratic equation. We all know this part. So if you use from this point, you factorize. Or if you don't like factorizing, you can use a quadratic formula. So your a is this one here. Your a is equal to 1. Your b is this part in front of x is equal to minus 5. And your c is not here. So if your c is not here, which means your c is 0. So your c, which is equal to 0. Then you can use the quadratic equation if you can. But I don't like it. So I will factorize this. So x squared minus 5x is equal to 0. I'll take out the common factor, which is x, because there's x this side. Because you see x times x minus 5 times 5x is equal to 0. So we have 2 of them. So take 1 outside. X, what are we left with? 1 times x minus 5 times 1 is equal to 0. So if you simplify, x, 1 times x is x, minus 5 times 1 is 5 is equal to 0. Is it still clear so far?
Yes.
Okay, so just took out a common factor. So now, if you have a situation where you have a times b and equal to 0, if you multiply two things and the answer is 0, what does that tell you? It tells you that at least one of the two things that you're multiplying is 0. If you have a times b and the answer is 0, that means either a is equal to 0 or b is equal to 0. So one of them should be 0, because if you're multiplying two things and the answer is 0, the only way you can achieve that is if one of them is 0. Is that clear? So if you have a situation where you have a times b and the answer is 0, it's either your a is equal to 0 or your b is equal to 0. You should always know this. So if you look at our situation here, we have two things that are multiplying each other. We have this x, which is out here, and this thing, which is inside this bracket. These two are multiplying each other, and the answer is 0. So what that tells you is either this one is 0 or this one is 0. So you have two brackets or two things multiplying each other and the answer is 0. One of them is 0. So in our situation, it's either our x is equal to 0 or what is inside, which is x minus 5, is equal to 0. That's the only way you can get 0 as a product. Because if this is 0, 0 times whatever this is inside, the answer will be 0, which is what you want. And if this is 0, no matter what this is, if this 0 times this, the answer will be 0. So you will get that your x should be equal to 5. So these are your solutions for the first one. We'll move to the second one, 1.1.2. So for the second one, you have x squared minus 2x minus 13 is equal to 0. Right? X squared minus 2x minus 13 is equal to 0. So it is already in this form, right? Because everything is in this side. So this is what you want. Then when you hear, they say correct 2 decimal places. So this correct 2 decimal places, I would take it as a hint that this thing does not have very beautiful factors. So it would be not easy to factorize it, or you might not be able to factorize it. So use the quadratic formula straight away. So it's some sort of hint that. So what you do, so you say x is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Right? So your x is equal to negative b. What is your b? B is equal to minus 2 plus or minus the square root of your b, which is negative 2 all squared, minus 4a. What is your a? Is 1. And your c is what? Minus 13. All divided by 2 times 1. This is how it should be. Did I substitute correctly? So punch it on the calculator. What do you get? What do you guys get? 1 plus square root of 14?
Yes.
So the answer is x is equal to 1 plus or minus square root of 14. Right?
Yes.
Which means x is equal to 4.74. Right?
Yes.
Or your x is equal to what? Minus 2.74. So these are the solutions for the second one. Straightforward. We all like these ones. So we move to the next one. So for the third one, 1.1.3, you have what? We have x minus 2 times a1 minus x is less or equal to 0. Right? This is what we are given. So, when it's here, or it looks something like this, it's fine, you are happy to go. Right? So, if your here is already factorized, you just find your important values, the significant values. So, you find your critical values. You say, now to find the critical values, you equate it to 0. So you say x minus 2 times 1 minus x is equal to 0. Are we all clear? Are we all happy?
Yes.
Also, before I even continue with this, let me go back a bit. So, if you're looking at this, on a normal day, you always have x minus plus minus a number, right? X. So, but here it's not like that. You have a number first. Do you see?
Yes.
So if you think it might be confusing, taking it this way, let's start with the x. You understand? So you can say, okay. Also, the bracket that you are operating with, the easy way, start writing with the bracket that is you want to make changes inside. Because you don't like it when it starts like this. You like it when it starts with a what? With a positive x. So what you should do, I would say, just write it and say, okay, just 1 minus x times x minus 2 is less or equal to 0. Still good.
Yes.
It's the same thing, but we just started with that bracket instead of this one. So this is this, this is that. You're still multiplying the same thing. It's more like saying 1 times 2 and 2 times 1. Just reverse the order. All good. So now let's write this again, but and start with the x now. So x is negative, so we have negative x plus 1, right? And x minus 2 is less or equal to 0. Are we still good so far? Okay. So now, the problem that we have now is that we have a negative here. We don't want to have a negative in front. We want to have a positive x like we always do. Right? So what you do, you take out the negative as a common factor here. So you say, okay, I will take out a negative as a common factor. So I'll have negative of what? Of x minus 1. So that this time this gives you this time that it gives you that. I all good. Times x minus 2 is less or equal to 0. So this is exactly the same thing. Just took out the negative as a common factor. So when you multiply by this negative inside this bracket, it still gives you the same thing. Do you understand?
Yes.
So the point of doing this is for you to know that the shape of the graph or the parabola that you're working on with, the parabola is negative, right? That means it will be concave down. But if you didn't fix it like this, it would not be easy, maybe if you're using the parabola, to know what signs you must use or what shape does it have. So you know that you are dealing with a negative parabola. So from here, say, okay, I'm finding my critical values. So you have negative x minus 1 and x minus 2. You equate them to 0. So, like I said before, z, if you multiply two things and the answer is 0, what does that tell you?
One of them.
At least one of them is 0. It's either this part is 0 or that part is 0, right? No one cares about a negative. It doesn't do anything. Because if this is 0, it won't change anything. So it's either this part is 0 or that part is 0. So it's either your x minus 1 is equal to 0 or your x minus 2 is equal to 0. One of these brackets should be 0. So you solve your x is equal to 1 or your x is equal to 2. Done. So now, when you are here now, you go and plot your parabola, your negative parabola. You say, okay, these are your x-intercepts. So this is my parabola. So there's 1 here, there's 2 here, right? It's negative, right? So it will have a shape like this. Are you all happy?
Yes.
It will be having a shape like this, facing downwards. So you want a parabola, weight is what? Weight is less than 0, weight is negative. Do you understand?
Yes.
We want our parabola, weight is negative. So weight is negative. It's negative here, right? It's negative here, it's negative here. Fine. We can see weight is negative. But what are the corresponding x values? The corresponding x values are these ones. These values here. And those values there. Because they must correspond with these x values. So these ones and those ones on the side. So these ones start from negative infinity to that point, and these ones start from 2 to positive infinity. Are we all good? So when you write it, we'll say our x is an element of what? Negative infinity. Actually, let me use the other side of the board. So we'll say x is an element of negative infinity. So x is from negative infinity to what? To 1. Is 1 included? Yes, it is included because we said or equal to.
Yes.
So to 1, then we say square bracket. That's how we show the inclusion. Together with what? With these ones. From 2 to positive infinity. Then round bracket. Are you all happy with that?
Yes.
Or 1 would say these x values, they must be greater than 2, greater or equal to 2. So 1 would say the x values should be greater or equal to 2, or your x value should be less or equal to 1. Less or equal to 1. This is the same thing. Are all good?
Yes.
Then we move on. 1.1.4. 1.1.4. Any questions so far? No. Okay. So, with 1.1.4, they have given something like 2 square root 2x minus 1 is equal to x minus 11. So these are called, so you are solving for x as well there, right? So the first thing that you want to isolate this to be on its own. Do you understand? You want the root and whatever it is to be on, and whatever number that is in front of it to be on their own. So this number here multiplies the root. Do you understand?
Yes.
This number multiplies the root. So this root is already isolated. It's on its own. Isolated means it's on its own. You want it to sit on its own side and then everything else to be on the other side. So we already have that. Then the next step, we want to get rid of this root here. How do we do that? We square both sides. So we square the whole thing and square the whole thing. Are you guys still with me?
Yes.
So if you square this, so you will have, if you have two things that are multiplying each other and they are both squared, each of them will be squared. So you will have your 2 to the power what? 2. Are you all clear?
Yes.
And what? And that's square root of 2x minus 1, then you square it as well. Is equal to, you can expand this bracket, so it's x minus 11 and x minus 11. It's two of them multiplying each other. Then, what do we have? We have 4, right?
Yes.
Times whatever the answer is for this one. So this and that go away. So you're left with what? 2x minus 1 is equal to this. You multiply this bracket out. If you multiply it, you'll find that you have x squared minus 22x plus 121. That's what we have. So simplify this. This time this is 8x minus 4 is equal to x squared minus 22x plus 121. Still happy?
Yes.
Then you transpose this to that side. So what I always do, I like transposing to that side. Because I don't, if I transpose this to this side, it will be negative. I don't like this thing when it's negative. I like working with a positive version of this thing. That's why you see me transposing to the other side. So now I have x on. I will have 0 is equal to x squared, which is this, minus 22x, which is that, right?
Yes.
Minus 8x, which is this one, plus 121, which is that, plus 4. What do we have? We have 0 is equal to x squared minus 30x plus 125. Are you guys following?
Yes.
There we go. You can use, so when you're here, you can use the quadratic formula or factorize. So let's try to factorize it. So 0 is equal to bracket, 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 bracket. So I have x, I have x. The factors of this is 25 and 5, right? So since this one is negative here, it's positive, which means these signs were the same. It's either they were multiplying each other, which is the signs of, because when you get that number by multiplying this one and that one. So if your answer comes out to have a positive sign, that tells you both of these answers were the same. It's either both positive or both negative, right?
Yes.
But if your answer here is negative, it tells you these signs were different, these ones. But we don't have a situation. We have a situation where we know both of them were the same. But how do we decide if they were both positive or both negative? You look here. If this is negative, which is both of them were negative. So we have negative, negative. So we have a situation where the product of two brackets is 0. What does that tell you? If the product of two brackets is 0. We have this bracket times that bracket is equal to 0. What does it tell you about the values of these brackets?
One of them is equal to 0.
At least one of them. It's either this one is 0 or that one is 0. So you have your x minus 5 to be equal to 0, or your x minus 25 to be equal to 0. So your x is equal to 5, or your x is equal to 25. So you got these things. So when you're working with this kind of equation, you have to test them. You will see the reason why we're not doing functions and inverses. So it's important to test the values. But the original that we had was what? Was just 2 square root of 2x, right? Minus 1 is equal to 11, or x minus 11. So Z, what is the sign of this thing here? Is it negative? The answer of this, will it always be negative or positive?
The sign of what? Of this side?
Of this side.
It will always be positive.
Yes, because whatever that comes out of this thing will always be positive.
Yes.
If this thing is defined. And this one is positive, so you're multiplying two positive things. So this will always be positive.
Yes.
Then, if you have a situation where your x value there is smaller than 11, your answer will be what then?
With the negative.
So which will not be equal to this.
Yes.
Do we have a situation here?
No.
Yes, we do. Look at 5.
Oh.
Our x value is 5. Our x is equal to 5, right?
Okay.
So you have a situation where this thing is negative, the right hand side. But you know this side will never be negative. It will always be positive. Because this 2 is positive, and whatever that comes out of here will be positive. So we know by just looking at this one will not go the way. Maybe that one will. So yeah. We're done with 1.1.4. We go to 1.2 now. Solve for x and y simultaneously. Are we still good so far?
Yes.
Yeah. So, yeah, because you all know how to test mass.
Yes.
Which is good. So now we're doing 1.2. 1.2 read as follows. Solve for x and y simultaneously. So you are given 2 equations. This one, I'm going to read it. Check if it's correct. 3x minus y is equal to 4. And x squared plus xy is equal to 24. Is that correct?
Yes.
Okay. So they wanted to solve for x and y simultaneously. So the first thing that you need to do is to look between these 2 equations. Which ones are you not scared of? Which one looks simple?
The first one.
The first one looks simple. It's a linear equation.
Yes.
You hope they give you a linear equation because it's the easiest one. So the one that looks simple, you solve for x or for y from. And look at your x there. You have a big coefficient of 3. And look at your y. Your y does not have that.
Yes.
Do you understand? So it's easier to solve for y than solving for x. Do you understand?
Yes.
Okay. So I'm going to rewrite this. So you have 3x minus y is equal to 4. So it's easier to solve for y. So what I'm going to do, instead of transposing this to that side, right, I will transpose the 4 to this side and transpose the y to that side so that the y becomes positive. Are you all happy with that?
Yes.
So I'm going to transpose this to the other side and this to this side. So we'll have 3x minus 4 is equal to what?
Y.
Equal to positive y. So this equation is it's coming from this one. It's the same equation, but just it's a rearranged version. We just arranged it so that it looks the way we like it to. Right? Fine. After rearranging the first one and solve for your y or solve for your x, depending what you want to solve, then you go to the one that you ran away from, the one that is scary, which is this one. You say, okay, I have the y, I have x and y's there. So I'm trying to get rid of the y's so that I can have the same variable everywhere. Do you understand? Then now, what you will do is say, okay, where I say y, I will substitute this 3x minus 4, so that there is no, we don't have multi variables there. You have a single variable. So you say, okay, it's x squared plus xy, which is plus x. Y, you substitute this thing here, because you said it's equal to y, right? So you substitute 3x minus 4 is equal to 24. Then from here, just expand the bracket. So you have x squared plus 3x squared minus 4x is equal to 24. What do you do from here? Just a group of like terms. So this and this, they are both squares, right? So they belong to the same class. So you add these two. This plus this is 4, there's 24 of them. Right? This one doesn't have anything that looks like it. So minus 4x is equal to 24. So, if you look at it, this is question 1.1.1 situation. And we said we would like to see it in the form ax squared plus bx plus c is equal to 0. Which means this one have to come to this side. Then with that, what do we have? We have 4x squared minus 4x minus 24 is equal to 0. Everyone good?
Yes.
Then from here, use your quadratic formula. Or you factorize. Are we all happy? So let's try to factorize. So I'll take out 4 as a common factor. Use quadratic formula if you can't factorize. So you have x squared minus x minus, what is 24 divided by 4? 24 divided by 4, 6. 6 is equal to 0. Then you can factorize this. So we have 4, this is equal to 0. So you have x, you have 3, you have 2, you have minus, you have plus. Right? Don't care about this. You can use your quadratic formula if you can. So I said this doesn't matter. No one cares about this. Do you remember we had a negative last time?
Yes.
I said this time, no one cares. If there's no x or something, no one cares about it. If it's just a constant, because we had negative 1 in the beginning. Alright guys, so what matters is what is inside here. But if maybe it was 4x, now it's a different story. Because if that x is 0, that one. If that x out there is 0, the whole thing would be 0. Do you understand?
Yes.
So, but now we don't. So, if you have two brackets multiplying each other and the answer is 0, it's either the first one, x minus 3, is equal to 0, or your x plus 2 is equal to 0. Then you solve for your x then. Your x is equal to what? 3. Or your x is equal to what? Minus 2. These are your x values. You say, okay, I found my x values to be 3 and 2. What do I need now? I need the y values. I said my y is equal to what? 3x minus 4, right? So, if your x is equal to 3, then your y is equal to what? 3 times 3 minus 4, which is 9 minus 4, which is 5. All good?
Yes.
Then, which means your coordinates are what? Are 3 and 5. Go to the next one. If your x is equal to 2, minus 2, right? Then, your y is equal to 3 into minus 2 minus 4. This is minus 6. Minus 2, what do we have? We have that your y is equal to minus 10. So your coordinates are minus 2 and minus 10. You're done with this one. Is it difficult? I don't think so. So now we will go to 1.3. So now we're doing 1.3. Yeah? So I'll read 1.3 and explain what it means. Right? So 1.3, they're saying let S be a product of these things. Do you understand? Do you know what a product is? A product is the answer you get when you multiply things out. So S is the answer that you get when you multiply all these things from this one up until the last one. Do you understand? Where the last one, it ends at this point here at M. They're telling that M is a natural number. Because you can see it's 7, 8, 9, 10. So even M is a natural number. Do you understand? And you're told that your M is bigger than 7 but less than 30. Does it make sense? So which means it stops this thing, this product of yours stops before 30. But obviously it's bigger than 7. Do you understand? Which means by that it's either these from here at least up to this one here. You're multiplying all of them, but for your M is less than 30. All good? Okay. So let me just read this question again. Calculate the values of M for which S will be a natural number. Show all your calculations. So they want you to find the values of M, right? Where this number here, this product here, is a natural number. I'm not sure if you understand what I'm trying to say. They're saying find the value of M where you multiply these things out and you get a natural number. Let's say you multiply maybe up until maybe 20, right? And then when you multiply them up until when your n is 20, and your answer comes out to be 6. 6 is a natural number, right? That means 6, which means 20, which I substituted here, is that possible value of m, because when we put 20 here, the answer that you get here is a natural number. Do you understand what I'm trying to say? Okay. Sorry?
Yes.
Okay. So what we're going to find now, we're going to find the possible values of m, which are going to give us a natural number. A natural number is a number that falls in this set. You can list them from 1 up to whatever. 1, 2, 3, 4, 5, whatever. So now, let's look at this thing closely. So it's s here. S is equal to 1 plus 1 over 7. What is 1 plus 1 over 7? If you punch this in a calculator, you will find that it's something like it's 8 over 7. Right? And then this one is 9 over 8. Do you agree?
Yes.
And this one is 10 over 9. And the other one is 11 over 10. You know how to multiply these. What do you do? Because you just this time that and then this thing continued, right? Until the last one there. So the last one is what? It will be m plus 1 over m. Do you agree? Okay. So this is the same thing as that. No difference. But look at it. This one will cancel that one. This one will cancel this one. This one will cancel that one. This one will be cancelled by the next one. And it will continue up until you get here. If you get here, you see that this one is the one that is going to cancel that one. Because it's always the bottom one cancelling the one before it. Do you understand what I'm trying to say? Or do you want me to find the one before this one? Okay. If you say maybe we find this term here. This term was 1, it was 1 over m, right? This one, the last one. So the one in front is 1 over m plus minus 1. Because these, look, these are natural numbers, right? And they increase by what? By these numbers, natural numbers are increasing by 1 unit. Do you understand? So now, if you are here, which means the one before it is 1 unit less. So which means the term before this one will be, if I write it in this way, it will be 1 plus 1 over m minus 1. Then the next one, because you add 1, you'll get that one. Are you happy? Are you sure? Okay. So to simplify this, it will be this time that m minus 1 plus 1 all over m minus 1. So this and that go away. So you'll be left with what? M over m minus 1. So this m will be cancelling this one. Do you understand? Are you happy now? Okay. I'm going to, so this one will be cancelling whatever that will be in front. So I'm going to clear this part because we don't need it really. So, do you agree with me when I say, what you will be left with here? You'll be left with 1 over 7 here, which is this one, right? And everything else in between will be gone. And then you'll be left with m plus 1 over 1. Do you agree with me on that one? Because this 7 is not cancelled by anything, but everything else dies. But this one will cancel that one, and then you're left with that one. So you're left with 1 over 7 here, and m plus 1, the last one at the very end. So, your s is equal to what? Your s is equal to m plus 1 over 7. Are you happy with that? Are you happy with that? Okay. So, now, they told you that the sum of this is a real number, is a natural number. Do you understand? They said this thing, your sum S, must come up as a natural number. But you can say that it's divided by 7. Do you understand that? So, if it's divided by 7, for it to come up as a natural number, for this answer to come up as a natural number, whatever is here should be a multiple of 7. I'm not sure if you understand what I'm trying to say.
Yes.
Because this thing, S is called m plus 1 over 7. But they're saying it should be a natural number, right? But, in order for this to be a natural number, this answer here to be a natural number, m or m plus 1, which is the top part, should be a multiple of 7, not m. The entire part should be divisible by 7. So now you can think of numbers. You can think of numbers between what? Between, let's say 7 and 30 that are divisible by 7. What are they? Let's write down the multiples of 7, right? With 7, 14, 21, 28. You can stop there because after this will go over. Do you see?
Yes.
So now, this one does not count because we say it should be m is greater than 7. Do you understand? But what you see here, these are not your m's. These are m plus 1s. It's things that are divisible by 7. You understand, Manti? Do you understand me? These things that you see here are not m's, but are things that are divisible by 7 on that interval that we give. Do you understand? So which means these are m plus 1s, m plus 1s, m plus 1s, m plus 1s. So you can take your m plus 1s and equate them to each of these things and solve for m. You will see the m's that will be in between. But do you understand what I'm trying to say? So you say, okay, m plus 1 is equal to 7. So which means the m is equal to what? 6. Is that m allowed? So that m doesn't count this one. So you can cancel it out. Because this m, which is 6, is not inside this interval here. Are you happy? Then we go to the next one. We say m plus 1 is equal to 14. Which means your m is equal to what? It's equal to 13. So is your m inside this interval?
Yes.
Which means it is, that one is correct. You can take it. So we go to the next one. M plus 1 is equal to 21. Which means your m is equal to what? M is equal to 20. Because you transpose this and solve for m. Will that one work? Yes. The next one is m plus 1 is equal to 28. Which is equal to what? Which means that your m is equal to 27. Will this one work? Done. That means your m should be any of these ones. 13, 20, or 27. That's it. Is it difficult? Okay. Yeah? Ah, super. What is tricky here? It's just understand the question. If you understand the question, then you'll be fine.